Welcome to the History of Math. What?
Today I will be taking you on a mathematical journey from the dawn of time to the beginning of the Common Era with the top 5 most interesting aspects of early math history. Beginning our journey in Africa, we explore the first evidence of counting with a written system. People would notch tallies into bones as a way to keep track of counting. This was the beginning of keeping track of items in a semi-permanent form. We jump 32,000 years to Egypt, where we continue to count. Here, counting takes the form of hieroglyphic numbers recorded on walls. The Egyptian number system worked on a system of tens rounded up to the next power. Although this system left out a lot of numbers, it was the first distinct counting system with specific symbols for numbers. Have you ever used your fingers to count? Measured the seconds in a minute or the minutes in an hour? What about remembering the number of degrees in a circle? All of these common aspects of math as we know them today began before the Common Era around 2700 to 2400 BCE, when the Babylonian-based 60 number system was introduced. This system of counting used your 12 knuckles on one hand to keep track of numbers. Today, the system takes root in having 60 seconds in a minute, 60 minutes in an hour, and 360 degrees in a circle. Back in Babylon, we explored the beginnings of modern-day textbooks with Babylonian clay tablets. These tablets contained fractions, algebra, and equations engraved into clay. This was a more permanent method than tallies on bones or hieroglyphics written on walls. In addition to more basic math contained on these tablets, there were sets of Pythagorean triples that were not discovered or named as such until much later. Can you imagine math without zeros? Moving to China, the decimal system, most similar to ours used today, was born. Before the discovery of zero, the decimal system used blanks where we currently use zeros. They did this so that they wouldn't have to create a new character for zeros, and they saw zero as a placeholder rather than a number. I'm done.
What? We begin at the start of the Common Era, 23 CE, where Liu Xin was the first person to use a geometric figure to approximate pi to 3.1547. Before, it has not been approximated to this point, and Liu Xin was a scholar who made many strides in math in the early first 1,000 years. Then, in the 3rd century, we come to Diophantus in his book Arithmetica. It is a collection of 130 algebraic equations known as the Diophantic equations now. He is known as the father of algebra. Also in the 3rd century, we had Hypatia, who was important because she was the first recorded female mathematician, and she paved the way for all of us female mathematicians. She was the daughter of Theon of Alexandria, and she was also murdered. In the 4th century, we have Aryabhata. He wrote the Aryabhata Bhatya. It was an arithmetic, algebra, plane trigonometry, spherical trigonometry, quadratic equations, power series, and table of signs textbook. He was the first major mathematician from the classical age of Indian mathematics. And then we come to the Mayans. They had a number system with a base of 20, and they were the first known to use zeros as a placeholder in their calendars. And they used tallies for all their numbers and a turtle shell for zero. That was terrible. I'm sorry.
Welcome to the 12th century. Bhaskara was one of the greatest mathematicians of his time. He gave birth to the differential calculus and helped provide the foundations of many math theorems. In the 1200s, oh wow, am I okay?
This is going well.
The 1200s brings your boy Fibonacci in his book Liber Abaci that presents his Fibonacci sequence, which is a fundamental concept in approximating series and sequences. KK, let's jump to the 1400s. 1440 marks the invention of the printing press, which led to widespread printing and circulation of math textbooks. In 1482, the first major math textbook was published, Euclid's Elements. In 1489, the first use of plus and minus symbols were found in a textbook written by German mathematician Widman. In 1492, Palos introduced the decimal point for organizing numbers.
Hi, my name's Albert Bradley. I'm here to show you all the important mathematical discoveries from the 15th to the 18th century. Let's dive right in. One of the more important discoveries was the publication of Newton's Principia. In this book, Newton discovered the fundamental theory of calculus and the three basic laws of motion for physics. Using these two concepts, he was able to discover the role of gravity in the solar system and is used in astronomy and space travel to this day. Our next discovery is Pascal's triangle. Pascal's triangle is a never-ending equilateral triangle, and it's calculated by summing the two numbers above the first one to get the next one, and so on in a never-ending way. This was discovered by Pascal himself, a 17th century mathematician, and it's used in a number of mathematical concepts or fields, from algebra and fractals to probability theory and combinations. Another major mathematical development of the time was that of analytical geometry by Volpe, the father of modern algebraic notation. In 1579, he published two books, The Introduction to the Analytical Arts and Canon in Mathematics. In these books, he uses a new set of notations which we understand today, such as the use of variables, constants, and the equations we see, as well as the decimal system we use. Building further on analytical geometry, Descartes took Volpe's work further and made the even more familiar notation we see today, such as the use of variables of x, y, and z, and exponential notation. With this, he applied algebraic work to geometric problems, so we could solve things such as the area of a triangle using algebra rather than measurements. Our last topic is that of complex numbers, discovered by Bombelli in his book that he published in 1572, which he named Algebra. In this book, he establishes the rules and basis of complex and imaginary numbers, using this to solve cubic equations which had remained unsolved before.
Hello, my name is Owen, Davey, and I'll be your mathematical news anchor for the next, hopefully, 2 minutes. I'm going to take you through my top 5 choices for best mathematical proofs of the last 2 centuries. That's right, I'm taking you through 1800s to present day. We're going to start in 1822 with our friend and yours, Fourier. See, Fourier wanted to model heat transfer from a high-energy substance to a plate. And he found that he could do this with differential equations. But upon differentiating the equation, he found that he got a series of trigonometric functions. These trigonometric functions can model any smooth function. And he found that it models the change in the function. These series are used in telecommunication and data transfer to this day, and it's one of the largest mathematical proofs ever done. Moving forward to the 1900s, we have our good friend Planck. See, Planck wanted to show why black-bodied substances could absorb radiation and never spit any out. He decided that it's because radiation had both wave-like and particle-like properties, showing that energy was quantized and had 2 states at the same time. This blew physics' mind at the time and was widely unaccepted until Einstein later proved it true. Speaking of Einstein, that brings us to our pick number 3. Einstein needed to show that the speed of light was constant, but in order to do that, he needed to find a model of the universe where the universe was constant. And to do that, he found this magical number called the cosmological constant. Doing so completely changed the way physics viewed the universe and helped prove the theorem of special relativity. This is one of the biggest proofs in physics ever done. Moving forward, if you wanted to model, let's say, a closed system like a hurricane and show the chaos that ensued because of it, you'd be in the same position as Lorentz. See, Lorentz wanted to show that chaos in a closed system grows, and in doing so, he proved this magical branch of mathematics called chaos theory. Like the flap of a butterfly's wing, It took over all of mathematics for a brief time and is one of the largest proofs and most important discoveries ever done. Finally, rounding out on number 5 on our list is the four-color theorem, which is finally proved by Apple and Honkin. See, we knew that the four-color theorem was correct and was true, but we couldn't prove it. That is until Apple and Honkin did this amazing thing of using a computer, widely unaccepted at the time, now utilized daily in mathematical proofs, shows us that we can let a computer do the number crunching, proving mathematical proofs through brute force instead of through careful thought. Thank you, I've been Owen Davey, and you've been great.
And that's all for now, folks.